Okay, so solving problems involving right angles is just everything's the same in this section, except there are words now that we have to convert into diagrams. And once we have the diagrams, it's pretty easy. It's the same thing as all the other questions. So there's two things you need to know in order to convert words into an image. And those are, where do I draw the angles that the question is asking? So you're going to get words like angle of depression or angle of declination. And you're going to get a word like angle of elevation versus angle of inclination. These are synonyms. These are synonyms. You can get one or the other. Now, this is the angle. The angle of depression is the angle measured below the horizontal. That word horizontal I underlined because it's important. If you're not drawing a horizontal, as soon as you see these words, you're probably going to be wrong. You're probably going to find the wrong angle. So let's say I find the angle of depression from this guy's eyesight. I draw a dotted line to simulate the horizontal. And the angle of depression is the angle underneath here. Underneath the horizontal. Okay, it gets tricky because you'll see in the next word problem, it's not the first thought. So if you don't draw that horizontal, you're going to be wrong almost always. Over here, angle of elevation above the horizontal. So I'm going to draw my my horizontal as a dotted line. Let's draw this a little better. It's kind of like this. Whereas this is upwards along the horizontal. Okay, so this is my eyesight. Here's the horizontal. There's your angle of elevation right here. And there's your angle of depression right there. But it's all with the horizontal. Okay, and that's just like from a guy's eyesight. So we can see how these are used in a paragraph style question like this. Kim and Yuri live in apartment buildings that are 30 meters apart as shown. The angle of depression from Kim's balcony to where Yuri's balcony reaches the ground is 40. So if this is Kim's balcony, this is Kim's balcony, and this is Yuri's balcony up there. The angle of depression from the balcony to where this building hits the ground, well, I'm going to draw this. Just mind the difference in the balcony. It's still 30 meters building to building. Let's assume the balcony is like inside the building. The angle of depression is not this guy, which is what you would think. The angle of depression from Kim's balcony is the angle from the horizontal here. That is the angle of depression from Kim's balcony to where Yuri's balcony hits the ground is 40. 40 degrees. Next, the angle of elevation from Kim's balcony to Yuri's balcony is 20 degrees. So if I go from Kim's to Yuri's, here to here, I'm gonna go like this, draw a line. Because my horizontal is already there, this is a really easy one. This is just a 20 up here. So the angle of elevation from Kim's balcony is 20. Okay, now there's a few things I have to assume in word problems, and that's like flag poles, buildings. These are all 90 degrees, right? These are all word problems that have to do with 90-degree angles. So we're always going to be using 90s. That's how we can't use SOHCAHTOA unless it's 90. So I got to figure out the height of Yuri's balcony. Where's my red? Gone forever. I want to figure out the height of Kim's balcony right here, and then Yuri's balcony right here. And you can already see, like once I find Kim's balcony, I just need to find the difference and then I can add them. So I'm already kind of thinking ahead of where this question is going to go. But I got to get started. So I have this 30. You can either picture this 30 being here, because it's the same thing. The horizontal is still 30 apart. Buildings don't get closer together as they go up. There's still 30 up there. Then I can use this triangle with the 40 if I want, and I can find this height, and that's Kim's height. And then I can do this 30 with this 20 and find this height, and I'm kind of already there. Okay, but it took a little bit of vision in order to determine that. Or maybe I don't see that. Maybe I'm going to use this 40 down here with my alternating angles. So I can call this 40 if you want alternating angles. Or I can use complementary angles and call this 50 from this 40. Okay? Either way, the best option to me is in neither of these. It's just use this 40 in this triangle because I don't have to write anything or think of anything that the question does not give me. So there's less processing there. So I'm going to use this triangle right here. And I'm going to say, okay, well, I got to find this height right here. That's opposite, and this is adjacent. I'm using tan. Opposite over adjacent. Okay, so again, how I determine, I'm using this angle. I have to find this. I have this. This is the opposite. This is the adjacent. Immediately, it's tan. I know tan is OA, so as I'm writing over here, I look opposite of 40 as H. I know it's H. It's not the hypotenuse H, it's just the height. And this is the adjacent, 30. Now I do 30, tan, 40 is H. And now I finally pick up my calculator. 30, 10, 40 equals 25.2. Look at the units, meters. So this is the height of actually Kim's building, right? Because we found this. We didn't need to find it on this side. We could have. Would have been the same thing. Okay, but I decided to find it over here, which is the height of the balcony, sorry. And now I got to do the same thing with this 20 over here. So I'm going to call this A. 20 with the A and the 30, this is tan again. Guys, most of the time word problems use a lot of tan because we talk about a lot of verticals and horizontal in the real world, right? We don't really talk about the hypotenuse unless it's like the string of a kite, you know, and it's like at an angle. It's usually all up and down, side to side. How far are you from a wall? How tall is the wall? So 10, 20 is opposite A over 30. And I'm doing the same thing. 30, 10, 20 is A. Pick up calculator. 30, 10, 20 is 10.9. Now I can conclude. Therefore, Kim's balcony is 25.2 meters high, and Yuri's balcony is, I have to add these together, 36.1 meters high. Okay, so I know Kim's balcony is this height, and then the extra, which is A, is 10.9. So I just have to add it to Kim's balcony, and I have that last answer for that last mark. Okay, pretty easy. There's a lot of options, though, that you can use in here, right? You could navigate through the angles any way you want. My advice is always try to do as little as possible, but that might be a little difficult at the beginning. Okay, three-dimensional questions are difficult, but only to draw, and I won't have you draw a three-dimensional question. I'll probably give you the diagram. Three-dimensional questions are actually easy because when you have 3 dimensions, you're always going to have a shared side length between the 2 triangles in the 2 dimensions. So if I have like one triangle here and another triangle touching that triangle, the key to the puzzle is always the shared side. It's always the key to the puzzle. Try to find that first and you navigate to the other triangle. So that's what makes it easy because it's always kind of that. Okay, this is a cool question because we can actually find the height of the cliff from one side of a river. If I'm on this riverside and I put a rock over here and I measure this length and put another rock over here, I can measure that to be 75. I'm able to do that. I can use a protractor to look at this large rock on the other side of the river at the bottom of the cliff. And I can use a protractor to see, oh, okay, that separates from the first rock to that rock. It's 52 degrees. Protractor, no problem. Very archaic instrument. Then I can use my protractor to solve for the 61 because I can look at the top of the cliff through a straw and I can use a weight, and that weight on a protractor can tell me the 61. It's an inclinometer. You guys use it in grade 10 when you go to Algonquin, right? To find the height of the trees and stuff. All easily found over here, all right? So with this information that I have, these are right angle triangles. Pretty big issue in 3 dimensions is sometimes you don't see that that's a right angle triangle, but there's a box, so it is. This is flat along the water and up and down on the cliff. It's just a little warped because that triangle is kind of like off-centered, so it doesn't look like a right angle. But if there's a box, guys, it's a right angle. So I need to find the height of the cliff. I'm gonna label it. Gotta find this. Probably not gonna have to work with that triangle, or else it wouldn't be a 3-dimensional question. I probably have to start far away from that triangle in this triangle? Well, I can find the shared side length. I'll call it A, because that's always the key to the puzzle. So I'm going to use 75 and this 52 to solve for A. Okay? Be careful when you're labeling your sides when it's 3 dimensions, because the dimension's warped. You might confuse your opposites and your adjacents and your hypotenuse, whatever. Yeah, the hypotenuse is always across the box. Here's the angle, opposite, adjacent, tan. Tan of 52 equals A over 75. Calculator time, 75 tan 52 is A. Get my calculator. 75 tan 52 equals 95.99. I'm going to call it 96. 96 meters equals A. Okay, and that's a pretty big deal. I now found out that A is 96. So now, right now I'm looking at this triangle. This is 61 as in the diagram. This is 96, I just found it. I need to find H, and this is a right angle. If you can link that triangle to that one. This is also easy. It's still tan. Opposite, adjacent. Tan is always used. H over 96. These are also all easy because I'm solving for the numerator, right? The H is never at the bottom, or the unknown is never at the bottom. So it's kind of always the same math. 96 tan 61 is H. Calculator time. 96 tan 61 equals 173.2 is H. Therefore statement to finish it off. Therefore, the height of the cliff is 173.2. Look at the units, meters. Don't forget your units or you'll lose marks. Okay, just as easy as the rest of the chapter. Just try to be an artist.